This is the resulting state from last transaction. I didn't actually finish it. So here's the network value for D and C. If we sum again the network values of all, it gives us 1,000, and if we sum the balances of all and their auxiliaries, it gives us 1,000 as well. So now let's say B makes a transaction to D of 120, and this time we check and we see that it is a forward value transfer. So in this case, it's not limited by the public rate of D or the public or the default rate of the network. So we're gonna say that B makes this transaction at 10%. So in this case, the direct link that would amount for, in this case, the 120, because it's just the forward value transfer. So we just reinforce all the links in the route by 120. This would give us 120 here, 140, 42 here, 142 here. This one also gets reinforced by 120, so we would give 174. B would be deducted 132, because it's 120 plus the additional, which is 12. So we would get 172, and D would get the 120, which means 600. Also, the auxiliary account of D would get in this case the 12, so it would get 21. Here we update here the conditions. So we have 3 incoming accounts to the auxiliary, and the condition is in this case 2 incoming links plus 1, 3. So it covers the condition to distribute this 21. We're going to check that later. Also, we have to update here the transaction rate for this link, which would be 11 if we make the pondering between 22 at 15 and 120 at 10. Would give us approximately 10 something, so it approximates to 11. And if we checked here, the network value for B would be updated to 314 if we made a calculation account here. 142 plus 172 would give us 314. Also here, if we made the calculation for the network value of D, would give us 303. So let's then make this distribution of D, of the auxiliary of D. This distribution, D doesn't participate in the distribution since the balance of D is greater than its network value. So it all goes to C and to A. In this case, the links rate is the same. So we're going to have to split this 21. In this case, we're going to favor the one with lesser network value, which is A. So we're going to say that 10 is going to C's auxiliary, weaken the link here, 134. And we send here 163, and we weaken here towards A, and this would get 26. We update here the condition to 2. Also, this one also has a condition here, 1, 1. So we're gonna see that this distributes and this one also distributes. So we're gonna see distribution reaction here. We have to clear them all for to finish the transaction, the original transaction. So C distributes this 10, so we got 0, 1 and 78. We check here, and we're gonna make this distribution here. So we're gonna have to distribute 26. In this case, A participates in this distribution because its balance is lesser than its network value, and distribute it backwards towards B. In this case, A, its public rate would be 5%, and B is 11. So we have to make this ponderation to 26 between the 5% and the 11%. This means, if we made some approximations, this means that A would get just 8 from the distribution, 132 here that will get from the distribution, and the rest, the 18, would go towards B, weakening this link. Would be 124. This would come here to the auxiliary of B, 18. This would get the condition to distribute, so we distribute in this case towards B itself. So this would get to 190 here, and that would be the complete transaction from B to D that generates a lot of distributions within the network. We evaluate again. Distributions don't alter network value, and network value, if we checked it, this amounts all to 1,000, and the balances, in this case, if we sum all the balances, we would get 1,000 as well.